are going to drive the need to save multiple model configurations in your Adams car databases. Because of the design of Adams car, it's typical to represent each unique configuration of a vehicle as a separate assembly. There are also different events that are going to require you to build uh, still further different configurations of your vehicle for your analysis. For example, you're going to need suspension assemblies as well as full vehicle assemblies that are of a particular GVW or driveline setup. So that's going to drive the need for additional vehicle configurations to be created and stored. Now, within Adams car, there's always been ways to add flexibility to a subsystem at the template level. For example, you could use switch parts or something called group activity together with switch parts. But this is something that requires expert template editing. Ultimately, we've always, when we're analyzing vehicle programs, had a need to create and manage many unique assemblies to capture all of the complexity that's required when you're analyzing a typical vehicle program in Adams car. So we have developed a solution that should help with this issue. There's a new capability in Adams car that is called assembly variants and subsystem variants. It was actually added back in Adams 2017, and it's a new capability that allows the standard user that is not using the template to create and manage variants of assemblies and variants of subsystems. The assembly variant allows the standard user to, for example, swap out entire subsystems or modify the parameters that exist at the assembly level to create a new assembly variant, and then to save that assembly variant in that modified configuration as part of the car database. The subsystem variant capability allows the standard user to modify almost anything about a subsystem and then save it to a new subsystem variant. The capabilities of assembly variants and subsystem variants can be used together, and this new capability also works together with the new capability event sets that we're going to discuss later in this presentation. So when we look at assembly variants, one of the things that assembly variants allow you to do is to capture different classes of assembly as variants. So when I talk about classes of assemblies, I'm talking about a suspension class versus a full vehicle class versus a generic assembly class. Typically, these three types of assemblies would need to be stored in their own assembly, separate from one another. With the current assembly variants capability, they can be stored together in the same file. Interestingly, this is enabled by another new feature that was added in 2017, which is called on-demand test rig activation. This feature actually allows you to store an assembly without the associated test rig. Previously, you needed to have the associated test rig stored with your assembly. So the benefits of this particular aspect of the feature are that you can now combine suspension assemblies, full vehicle assemblies, and generic assemblies into one single assembly file as multiple variants of that vehicle model. So the assemblies are now portable between events, which use different test rigs. The on-demand test rig activation feature will now actually automatically load the associated test rig with the event when you load that assembly into the event. So assembly variants also allow you to model vehicles to different degrees of fidelity. So for example, if you typically have a fully rigid model, or you then create a beam version of that model, or a flex body version, they would typically in the past have needed to be three separate assemblies. Well, now those could be variants in the same assembly. Further, the real-time and non-real-time versions can be stored as separate variants in the same assembly file. Finally, we typically end up using different types of models for handling versus durability type events. And so models that are tailored for particular types of events can also be stored as variants within the same file. So the benefits, as you're probably starting to realize, would be a reduction in the number of models that you need to manage. But an interesting side benefit is that the effective changes to models will no longer propagate through to require a completely new assembly. It limits the scope of work that's necessary to implement a change to your design to just a subsystem variant. So the assembly variant capabilities also allow you to, in summary, I should say, they allow you to change the assembly class, allow you to change subsystem and subsystem variants that are part of that assembly. They allow you to change the plugins that are active for a particular assembly variant. You can optionally specify a test rig or not. And the solver settings that are the defaults for that assembly are also part of an assembly variant. So the way that that's all implemented is that the assembly file has what we call a default assembly, which stores all the details for that assembly. And it then records what is different from the default assembly for each assembly variant. The result here is a very compact and easily readable format. An example would look something like this. In the assembly file, you see here a record or a block that represents the driveline subsystem here. And we can see that the default driveline subsystem is this driveline, rear-wheel drive limited slip. And it is noted here that it's called this R-wheel drive, rwd2.sub. We can see that that is used actually in a variant called rear-wheel drive and rear-wheel drive performance. Excuse me, I said that was a default. This is a variant that's used in these two assemblies. And by the same token, we can see that when we're talking about the engine subsystem, we have a subsystem variant. We could tell that it is a subsystem variant because it is the engine transmission longitudinal subsystem. This double semicolon or double colon represents the indication that there is a variant, and it is HP for high performance. So what we're seeing here is that the assembly variant called rear-wheel drive high performance uses this high performance subsystem variant of the engine, and it also uses the rear-wheel drive 2 subsystem for the driveline. So as you can see, this is fairly easily readable. So we've provided you with a nice capability for switching variants in the interface. If you look down here in the status bar, you'll see that we've created a new icon here, which looks sort of like a shift pattern. And when you select that icon, it opens up an assembly variant switcher. So it will show you the current assembly variant that is loaded. And if you select the drop down below that, it will show you the available assembly variants. So you can select that, click OK, and it will switch to a new assembly variant. Very quick and easy. So let's talk a little bit about the subsystem variant capabilities. In a subsystem variant, you can change and save pretty much anything that defines that subsystem within its template. The benefits of that include being able to model different vehicle models, such as a sedan or a coupe, or different configurations of things like driveline or powertrain, such as an all-wheel drive versus front-wheel drive. And where you have different setups that are needed for different types of analysis. For example, the vehicle GVW or tire types that can be captured. In all, the hard points, parameter variables, general parts, switch parts, flex bodies, FE parts, FE part sections, nonlinear rods, anti-roll bars, any user-defined elements such as springs, dampers, bushings, rebound stops and bump stops, and so on. Any gearing, general parameters, general splines, and general variables are items that can be different between subsystem variants. When you look at the file that defines a subsystem variant, what you'll see is the definition of all the detail for that subsystem. And here we've got that abbreviated. But what you'll then see below that is a section called variants. In the curly brackets or braces, you'll see the name of a subsystem variant, and then any particular item that is different than the default will be noted here, but only that particular item. So in this example, this subsystem variant called variant test differs from the default only in that this one hard point is different. And in this case, below, you can see this part, which is the lower control arm, differs from the default assembly in its mass and moment of inertia properties. So the final thing that we'll talk about here when it comes to subsystem variants is the fact that we give you the ability to manage these subsystem and assembly variants in the interface. So we've added a bunch of new commands in all the places where you would normally manage both assemblies and subsystems. For example, here where you would normally see manage assemblies, you now have commands that would allow you to switch between variants, delete a variant, or manage an associated test rig. Or you might, when you go, for example, to save a subsystem, now see a new drop-down that would allow you to update an existing variant or save that variant as a new variant with a new name after you had possibly made some modifications. Or you could delete all the variants and just keep the default and set the current, whatever the currently loaded subsystem variant is, to the new default. So the benefits of all of these new commands are that they allow you to easily create new variants, modify existing variants, delete variants, select variants for use in analysis events, and publish specific variants to new databases. So all the things that you would normally do in managing your subsystems and assemblies now incorporate the concept of variants. We're going to jump into a quick live demonstration of the use of assemblies and variants. And if you have any questions at this point, you might want to start recording them in the chat window. We'll get to them later. But what we're going to do now is just quickly walk through how to use assembly variants, and then we'll do a quick walkthrough of how to use subsystem variants. So we're going to first open a file that should allow us to take a look at assembly variants. I'm going to open something from my private assemblies, and it should be the sedan variants. Okay, so we can see that we have a typical sedan vehicle here, which I believe is part of our some of our default assemblies that we ship along with Adam's car for examples. We're going to go ahead and go into File Manage, and we're going to go to the switch variant operation. We can see that right now we have a number of subsystems that we can, oops, you know what? Actually, I meant to go into assembly variant, sorry. Manage assemblies, switch variant. And if we go ahead and look through the list of variants that are a part of this current assembly file, we'll notice that in addition to the default, which is what loaded up, there's also an all-wheel drive and several other. We're going to go ahead and select the rear-wheel drive variant and click OK. And you'll notice that the vehicle assembly will update by loading in that assembly variant, and we can now see that what was a front-wheel drive has now got a prop shaft in it as a rear-wheel drive assembly. If we go ahead and select the assembly information, we can see that if we look for the, well, we're going to get right here. So the default assembly we can see has we can see actually that the contents of all of the assemblies and their variants are listed here. And for example, in the powertrain category, we've got the engine transmission transverse, and in the suspension and driveline category, we've got this front McPherson strut and multi-link rear suspension. And we can see that the variant that is indicated there is default for that. Now if we scroll down to the rear-wheel drive variant, which is here, we can see that the engine transmission longitudinal subsystem is the powertrain that is used, and that the suspension is now a rear multi-link and a demo front suspension, which is different than the default variant. If we now go into View Subsystem and select the, we're going to go ahead and select the engine transmission longitudinal subsystem. What we can then do is go into Adjust Powertrain Properties. And what we're going to do is we're going to make some changes to this subsystem. As you can see, right now it's an automatic torque converter setup. We're going to go ahead and select robotized clutch. And we're going to go ahead and select a different variant of the powertrain. We'll switch it to a V8 400 horsepower. And then we can click OK. So we've now made modifications to this subsystem from what was originally there, or loaded, or defined, I should say. And now what we're going to do is go to File Save As for this subsystem. And as you can see, we have the ability to now select new variant, create a name for that new variant. I'll call that HP. And hopefully that's not previously defined. And then we can go ahead and click OK. And now we've created a new variant of this subsystem called HP. If we go back to the model browser and in the assembly view, we select File Assembly Save As. So we're going to go ahead and get back into the view of the assembly. And now that we've modified this engine, the powertrain subsystem, we have what would now be a unique assembly. And so if we go to File, Save as Assembly, and we select New Variant, we can create a new variant called rear-wheel drive high performance. And then we can click OK and save that new assembly variant. So we've made changes to a subsystem, and we have then saved the assembly that contained that modified subsystem as a modified assembly. If we want to, we could go ahead and open up the assembly file and the subsystem file and see the modified content, but I think we demonstrated earlier what that would look like. So if we wanted to now use this assembly in a simulation or some other assembly in a simulation, we could then go into our vehicle analysis events and select, for example, the constant radius cornering event. And we can see now up at the top that we have the ability to select an assembly variant for use in that. Currently, we've got this rear-wheel drive high-performance assembly that we just created loaded, but if we wanted to use, for example, the all-wheel drive variant, we could then load that, and you can see that it would load that all-wheel drive variant. We could set up a prefix for that. Go ahead and select an output size or step size. Select a velocity and set up this subcase to run for 10 seconds with initial acceleration of 0.6 and a final acceleration of 0.8. And obviously, we now have loaded that variant and told it that we would run this assembly as the assembly to analyze. And if we click OK, now we could either click OK and it would automatically load the assembly and analyze it, or if we wanted to see it before we ran the analysis, we could, whoops, well, I guess I made some kind of a mistake there putting in the input. Sorry about that. But the whole point here is that we could either select the assembly and then load it immediately, or select the assembly variant that we want to use and click OK, and it would be loaded at that point for the analysis. Moving on, if we wanted to go ahead and, for example, show that this assembly also contained a suspension analysis, we could go into suspension analysis. Let's say we wanted to do a parallel wheel travel analysis. We've still got this sedan variance assembly loaded, and as you can see, we're looking at a full vehicle assembly. But if I wanted to go ahead and specify a suspension analysis, and click this load assembly button, we would see that it would now load up the suspension assembly, which was stored as a variant in the assembly file, and we could then go ahead and run our analysis. So that's just a quick walkthrough of some of the features we talked about. So what we're going to do now is take a look at the subsystem variants. So I'm back here now in an empty Adams car session, and we're going to go ahead and we're going to open up a subsystem file, which is part of the ACAR shared, and it is the familiar TR front suspension, or TR front suspension subsystem that you may have used as an example many times. So this is part of the one of the example databases. What we could do here is we could make a number of adjustments. For example, we could come in here to modify the hard points that are associated with this subsystem. And for example, we could select the upper control arm front, which is now 367, and we could change that to 200. And click OK. So we will have modified one of the hard points. Then we could, for example, go into the upper control arm. Let me slide this over so we can see the whole thing. Could go into modify the upper control arm. You can see that it's got this data that's in here for the mass, but actually, because there is geometry associated with this, you always have the capability of selecting material type and then clicking Calculate Mass Properties based on geometry. So we're going to go ahead and do that. You can see it modifies those geometry properties. Excuse me, the inertia properties. We can click OK to save that change. And we could do the same for the lower control arm. We could further go ahead and select the spring. And, excuse me, actually we could go ahead and select the spring and then use the replace function to replace that spring with, for example, an air spring. And we'll go ahead and click OK and accept the default definition for the air spring at this point. And we could go even further, and let's say we're going to modify some adjustable forces here. So we're going to go into adjust, adjustable force. We will then go into the camber adjuster. Right now that's set at negative 0.9. 0.4 will make it negative 0.9. Apply that. And then we can go ahead and select the toe adjuster. Currently set at 0. Make that negative 0.1. Another type of change you could make that is going to be acceptable would be to change parameter variables. So if we go into parameter variable, modify, and we select, for example, the PVS hub compliance active, which would switch our hub connection to the wheel from a rigid or from a joint to a bushing. And right now let's set it 0. If we select 1 and apply that, that would change it to a bushing. You can see the bushing appears there. The driveline activity is inactive. We could make that active. We can see the driveline components now appear. And finally, we have a switch part that we can make a change to. Here's the anti-roll bar connection point, and currently it is set at the upper control arm. We can change that so it's now attached to the lower control arm. So as you can see, we've made quite a number of changes to this assembly. What we're going to do now is go ahead into File, Save As, and we're going to create a new variant, and we're going to call it Variant Test. Oops, didn't want to do that. Not that it matters. So if I click OK, we have now created a new variant of that assembly. And what I can do is we can quickly take a look at the subsystem file that was created. I'm going to open that over here on another screen and pull it over really quickly. It's in my private CDB under my subsystems. And if I were to go and open this TR front suspension sub in Notepad, which I just did, and sorry, you didn't need to watch me do all that, but the point here is now we can take a look and see that in the hardpoint section, we can see that that upper control arm change that we made is here under this variant section. And if we go down to, there should be a switch parts section. Well, actually, let's look for the lower control arm. We can see that we've got the properties, the mass and inertia properties for the default, and then the variant are saved here. And we could go through and see the similar types of changes for the other areas that we indicated. So it's really quite simple to look through the subsystem file and identify what is different for a variant in the ASCII version of that subsystem file. And we could actually now go here and show that you could go to Manage Subsystem Switch Variant, and right now we have the variant test loaded. I could go right back and reload the default assembly. And now we still retain all of the definition of the default assembly, as you can see, in its original state. We're going to go ahead and take a look at another subsystem that displays a different capability very quickly. I'm going to open the subsystem, which is called Subsystems. Generic body sub. So the generic body subsystems definition by default looks pretty boring. You guys are probably familiar with the body subsystem not having a lot of definition to that. But in this particular case, what we have in addition to the normal default is that we have some variants created that would allow us to switch the bodies. So if we take a look at the file associated with this, which if you give me a second, I will open up here. In a notepad, sorry about that. We can see that this generic body subsystem, in addition to having what would normally be there as information just to define the inertial properties of a rigid body subsystem, also has variants that include what these geometry files. So we can see that there's a couple different graphical geometry options that are available and associated with variants. And some of them have also additional mass properties. So the point is that we're able to define some variants for the mass and associate geometry. So we could, for example, go to now Manage Subsystems Switch Variant. And as opposed to default, let's take a look at the convertible subsystem variant. And we can see that what gets loaded is the convertible geometry and also its mass properties, as well as we have a subcompact variant. And there's a third variant that would be yet different again. So the ability to save external geometry as part of a subsystem variant is now supported as well. So that would be the end of this demo. So let's get back to the presentation and cover the second section of our webinar, which is the topic of we've got a couple more benefits to cover with variants. Quickly, if we were to take a look at a typical example here where we've got these 12 assembly files that are needed to do all the work to analyze a particular vehicle, we can see that there's a combination of full vehicle assemblies. There's a set of four-post assemblies, one for each variant of the vehicle, a base, a sport, and a long wheelbase, for example. And then we've got suspension assemblies for the front and the rear. With the assembly and subsystem variant capabilities, we could literally replace these 12 with a single assembly and its variants. And the resulting savings in this case takes us from a total of 34 files down to 10, 12 assemblies to 1. And that one assembly now contains 9 assembly variants, fewer than the number of assemblies because actually the test rigs become optional. And so we no longer need a separate full vehicle assembly for the 4-post. So ultimately, we have quite a bit of savings in terms of number of files that you need to manage. So let's talk about event sets, which is where I thought I was going, but now we're there. So the issue that inspired us to create event sets was the question of how do I capture the standard analysis work that's needed to evaluate a new vehicle or design change and make it repeatable. Many users manually set up multiple runs and then run them in batch using a command line uh, script or custom macros which launch multiple jobs. Um, the goal of repeatability is actually not very easily attained using this setup. Um, there's a lot of manual file manipulation required, and the process can actually be difficult to uh, duplicate by a different user than the one who set up all the scripts and macros. So uh, beyond that, if you are trying to run parametric studies using something like Adams Insight, that actually then requires a completely different type of approach. So looking at that problem, what we did was to create a new capability called event sets. The event set capability actually is supported by the creation of two new objects. Uh, pardon me for getting into computer speak, but there is an event object and an event set object. The users can now create new events, group them into event sets, run them, modify them, check the status of their execution, and also create reports and plots from these results. Export these events and event sets, share them with other users, and import them from the saved configuration. And we'll get into all of these capabilities in a tiny bit more detail as we go through here. So if we look at the event, we've used the term event in the past, and actually with this new capability, the definition of an event is somewhat expanded. So each event now contains all the data that is needed to create and run a specific simulation. That includes what we used to call the event XML definition, but further it includes the road data, the vehicle assembly or assembly variant that is associated with that specific event, the event parameters, and solver settings. So this expanded event definition essentially combines what were previously several different files and makes a full definition of the event that is persistent. It further makes it very easy to run the same event in exactly the same way with a different vehicle or a different vehicle variant. Now, the event sets are pretty obviously a collection of the event objects. They can reference the same vehicle assembly for each event, or a completely different vehicle or assembly variant could be referenced in each of the events in an event set. You can actually have multiple event sets loaded at one time. And the benefits of the event set object are that it allows you to define and run a whole set of analyses needed to characterize a vehicle, for which some people who've used Adams chassis in the past might recognize as what we used to call a fingerprint capability. And you would then have as well the ability to use these event sets in combination with Adams Insight to define parametric studies, which is an additional benefit. And finally, it makes what we would call standard work in the auto industry repeatable and shareable. The ability to manage these event sets is also provided so that users can very easily create the event set and manage the objects that are part of it, so that within what we call the event browser, you can easily add, modify, delete, run, monitor status, review, export, and import an event set, all from within the GUI. So it's very easy to launch and process large studies. The actual event browser, which we see an example of here, is similar in its design to the model browser. It visualizes an event set and the events that it contains and allows you to manage them. The event browser is supported by a new button down in the lower right corner of the status bar. This is it right here. And when you click on that, it opens the event browser. So you have quick access to that. It's a powerful new job management tool, and it makes it quite easy to manage large studies and their results. You have the ability with the new event browser to quickly generate reports. So you can right-click on any event that has the status of complete and click Review, Generate Report, and a text report will be generated and displayed in the report window. It is a standard report for each event. So you now have one-click access to a standardized text report for each event. Further, you have the ability to quickly generate plots from your results. There's a standard set of plots or cross plots that can be launched directly from the event browser very quickly and easily. The set of plots is controlled by a plot config file, which is a standard for each event, but we've given you the ability to actually customize these plot configuration files so that if you have a particular need for your plotting, you can easily meet that need with a customized plot configuration file. So you have one-click access to a standardized set of plots by event for each event, and it's actually quite easy simply by selecting two events and the plot operation to generate a cross plot to compare results of design changes, whether you're using our standard configuration files or your own customized configuration files. So let's take a quick look at the capability for event sets. One second, I'm just cleaning up the work from the last time here. So we've got the empty Adams car window, and what we're going to do is we are going to open up the very familiar Adams MDI demo assembly. So if we were to go and select for example, swept steer event to create a swept steer analysis, you'll notice when we look at the analysis mode drop down, you see the familiar interactive background files only. There's now a new category called event only. So if we set up the event to run as we normally would, we could go ahead and select event only, click OK, and what we would see now is that our event browser pops up. And oops, well, I guess I already had something left over from there, so let me get rid of that. So our event browser pops up and it shows us this new test one SWP for the steering sweep event. So we could then come in here and right click on that event and make a copy. We can see that we now have a copy of test one. I could come in here and rename that to test two. And I could come over here and, for example, modify that test one, new test two, so that it is different than test one. I could, for example, make that instead of 100 miles an hour, 100 kph, we'll make it 65 kph, and we'll change the lateral acceleration 0.45 and click OK. So now we've got two different events, test 1 and test 2, that are both swept steer events. If I want to confirm that these are different, I could, for example, click the info and see that the test 2 now is 65 kph and 0.45 lateral acceleration, so I can confirm that that change was made. And if I wanted to, I could now come here and interactively run both of these cases by clicking on the event set, which is called default, and you can see that that's the active event set. And if I just click Run Interactive, you can see that those two cases are going to be run. In sequence. So I've got those two events complete. And I could, for example, come over here to the test 1 and quickly show you that here's the standard swept steer report. It's a text report with what you would typically be interested in knowing from a swept steer event. Now, now that I've got these two, and you can see it switches to a little green icon to let you know that the event has been run. I could go ahead here and I could make a copy of this entire event set. If I right click on the set and click copy, you can see that I've got default and then I've got default copy of the event set. It's still using test 1 and test 2 as names. So why don't I come in here, click modify, and change this to test 3. And this to test 4. And if I like, I could actually, right now I'm using the obviously the Testarossa. If I wanted to have this second set use a completely different vehicle, I could now come up here and open another assembly. For example, let's open the demo vehicle LT assembly. And what we're going to do is we're going to associate that assembly with the second event set. So you can see that that is loaded. And I can come in here and right click on the event set and I can select replace assembly. Right now it's since it's a copy of the first one, it's using the MDI demo vehicle, but I can select demo vehicle LT and click OK. And now if I click the info on that new event set, I can see that it is using the event set LT, excuse me, MDI demo vehicle LT. So I could go ahead and run the second new event set. With the different vehicle. Okay, I've got now swept steer results for the demo LT vehicle for those two cases. And I could, for example, come over here and generate a set of cross plots that compares these two vehicles by first selecting the two cases, test 3 and test 4, which I can see are done because I have a green check next to them. Go into review, generate plot, and I have a set of plots that were generated based on the plot configuration file that I can review and see the differences between those two cases. I have the ability, now that I've defined these cases, if I want to be able to repeat them, to go ahead and save the definitions that I've created. An XML file is going to be created to save that, so I can, for example, take the default um, event set and click Save. I could take the default copy and, for example, now delete that. And if I right-click in the empty space, you can see that I can import an event set. So let's go ahead and click Import Event Set. And if we look a little bit further down here, we'll see something called default.xml. That was the name of the event set that I saved. So I'm going to go ahead and click OK. Oops, I apologize. I meant to delete the other one. So I'm going to go ahead and choose Replace. But the point here is if it had been saved, it can be recalled exactly as it was saved. My apologies for deleting the wrong one. So now we've recalled that event set that we would have, if we had done this correctly, deleted. So that pretty much shows you the capabilities that we have with the event browser.